Example 15. Now, just take note that you can actually sketch the derivative graph, which is f prime x, by entering this on your GC. Okay? You want to try now, go ahead and do it. Okay? You can actually get it out. But this function, can I have attention? This function of using the GC to get the f prime x graph out will only work if I know what is the equation. Okay? It will only work if I know what's the equation. More often than not, the question may not give you the expression fx. So this only works if I know fx is this, I want to derive f prime x. I will key into a GC. But more often than not, the equation is never given. But what we can do is, okay? What we can do is make some observations about the relationship between fx and f prime x. Okay. Now, is it obvious to all of us? No need to copy, no, the graph no need to copy. Okay, this is a nicer, high-res version of what you see on your GC. Okay, the blue, let me orientate all of us. The blue is the original graph. The red is the derived f prime x graph. Is it obvious to all of us that for this entire section whereby the blue is increasing, that means this, right? That means the gradient is positive, 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 positive. The derived graph lies above the x-axis. No surprise. Follow what I'm saying? Correct? Similarly, for here, is increasing. The gradient is positive, positive. And for this corresponding portion, this part is above the x-axis. That's observation 1. So, point number 1, if fx is increasing, f prime x should be larger than 0. A consequence is actually it will lie above the x-axis. Follow? More importantly, it will lie above the x-axis. Of course, the reverse is true. The reverse is true. If this portion it is decreasing, then this red portion derived graph should lie below the x-axis. Quite obvious. Follow what I'm saying? Because this part is decreasing, so this entire derived graph will lie below the x-axis. So f prime x is negative. So maybe I should add this is above x-axis. This is below x-axis. We'll put that into practice later on, but I think it's a worthwhile exercise for us to do. Now, I want to bring your attention to two special points. I want to bring your attention to two special points. One, this, and the other one on the blue graph, 2 points here. These two are what we call stationary points, right? Stationary points means dy dx equals to 0, right? Dy dx equals to 0 means when you sketch the red graph, at this particular point, the dy dx must be 0. It must cut the x-axis. At this particular point, it must also take on 0. That means f prime x must be 0. Correct? So, is it obvious to all of us, if a at x equals to a, y coordinate can be anything, is a stationary point, then, therefore, at A, f prime A is 0, which means that A0 is a point on this derived graph. Make sense? This R is a positive R or negative R? Good, thank you. Okay, the last point is slightly trickier. Remember on Monday we talked about concave upwards, concave downwards. Correct? Concave upwards, concave downwards. Now, we look here. We look here. This entire portion forms part of a Smiley face. Correct? This entire portion forms part of a Smiley face whereby the dy dx increases. Remember what I said? As long as it's part of a Smiley face, it means concave upwards, where that means dy dx increases, which means d2y dx squared is positive. Correspondingly, if dy dx, if it's concave upwards, it means that the dy dx actually increases. Look at this portion. From here, it increases. Okay, a very natural question you would ask is then, how would I know where will it start? Where exactly is the x-coordinate of this point? How would I know? Actually, if you don't know what is the equation, you will never know. You will never know. This happens to be a point whereby the curvature changes from concave downwards to concave upwards. This there's a name to this point. This point is called a point of inflection, where it changes curvature, point of inflection. Don't need to really know, but just for info. Correct? It changes from a sad face to a smiley face. This is called a point of inflection. My point is, if it concave upwards, it will mean that your dy dx increases like that. You see, this point increases like that. If it concave downwards, then your dy dx actually decreases like that. Follow? So to put in words, it just means this. Follow? Can? Okay. Then we put that into practice and see some examples. Oh, sorry. Can?